Okay, again, irrigation. It's going to look different in a greenhouse because you can't usually just flood it. You usually have overhead irrigation. More popular, you're going to have a hose that runs and puts a little bit in each pot. So you're not going to, when you do it overhead, it gets water everywhere. It's a waste of water. Even if you recycle it, you're looking at a lot of like algae and fungus and things that just get in the water. So that's not ideal when you build a greenhouse. Obviously, you want more of a drip irrigation system. Sanitize is really, really important, especially if you're overhead irrigating. You want to use UV light, copper ionization. You want to monitor for adjustments of fertilizer and concentration, especially if you're putting fertilizer through your irrigation. Okay, again, furrow irrigation. You see this in the south. Cotton is furrow irrigated, so you have a little hill. You plant your cotton here, and then you irrigate on either side of the hill, right? So here's where your irrigation goes, but your plant doesn't get flooded because it's planted on top of this little hill. That's called furrow irrigation. Sprinkler irrigation, again, this is not very common. You see center pivots out in Nebraska. It's a circle where it irrigates, and that actually irrigates their nozzles, and then you can put fertilizer out through that as well. Sprinkler, again, this is really expensive. Main line of the field, you can have them moving back and forth through the field. Most likely they will be a center pivot, so it'll go in a circle. Water flows to the laterals out the nozzles, and you can move it from field to field if it's on wheels. You will see a lot of them that are on wheels. Mostly they stay in that same field. It's really expensive, and it's just nobody moves them. It's really rare for one person to move the super large ones from field to field. You can do it, but it's not ideal. Sprinklers, there are some that just are permanently buried. You will see this in nurseries. You will see in nurseries situations where the lines are buried and that pop-up riser. That's a very common situation in nurseries. You don't see that in crop fields, especially landscapes, golf courses, and sports fields. You will see that. Sprinkler designs. There's just a million ways you can make a sprinkler design, depending on if it's outside, inside, nursery, if it's permanent, not permanent. There's just a bunch of ways to go here. You can do a wheel, you can do a pipe. The most effective, honestly, is going to be some kind of a drip irrigation system. Same thing, nozzles, probably the best system. This is what I was referring to as a center pivot. These wheels roll and it actually goes, you can have one that goes in a line like from here to here, but mostly they go in a circle, and there's a pivot here that's attached to the well, and the rest of it goes around in a circle. So that's why they're called center pivots. This one has these that go down further into the corn or whatever. It's called a drop nozzle. It's a new system for the center pivot to try and not lose quite as much water. These are getting controversial because places that don't have enough water, they're pulling this water from aquifers, which is the underground water, and it means that other people aren't getting water. So the Ogallala Aquifer, which shares Colorado and Nebraska and Wyoming and parts of Kansas, Denver is draining it really fast, and so is agriculture. So there's a lot of debate about who should get that water, and many people feel like this isn't a great use of water. Depends on your perspective and whether this is your land or you live in Denver. This is probably the most effective. Trickle irrigation, essentially, these are definitely for high dollar horticulture crops. Basically, this is going to bring in water, and it's just going to drip it right here. See, it's only getting water right here. You're not getting evaporation. This is the most efficient way to water. It trickle into the ground. It's kind of like a leaky hose. It directs the area right to the plant or the pot, and this is probably 75% of irrigation in horticulture crops. You're going to be irrigated like this because it just is the most efficient. It uses less water, there's less fluctuation in water availability, there's less interference with other operations because it's just on the ground, and it is the most efficient. Disadvantages, sometimes it can be unevenly distributed on hilly land, salts can accumulate, and their roots can be restricted in the wetter areas. So those are just things you need to watch out for. You can have these done manually, where you turn them on when you need them. Obviously, that's the most efficient, or automatic. Timers, that's not great because you could be watering while it's raining. I've seen that happen. So that's not a great way to do it, but some places do it because they're just gigantic and they have to do it that way. Automatic is usually, if you have really high dollar greenhouses, you will see them take in all the weather information in the greenhouse and only irrigate when there's a certain light intensity, or they're actually taking the pressure of each pot and doing them separately. A computer usually does this. It really looks at relative humidity, VPD, evaporation potential, soil factors. I mean, it's like a massive calculation all the time, and it only waters it when that's absolutely necessary. That's ideal, but of course extremely expensive. Drainage. You want the bottom of your pot preferably to have a little hole in it so it doesn't get waterlogged. You want your soil to not hold too much water, but be able to hold soil. You want your pipe for drainage to be underneath the field so that you don't hit it. If you have a drainage pipe underneath the field, you want it to be far enough down so if you do cultivation over it, you won't hit it. So that's usually about 6 feet, 4 to 6 feet. Drainage systems in the past harmed ecologically necessary wetlands. So in Florida, they're putting the wetlands back. Newer systems are designed to retain the wetland effect. So in essence, you can drain your piece of land, but it has to go back to where the water was flowing on not your piece of land if there's a natural wetland there. Fertilizers supply nutrients to crops. We've talked about this. Obviously, they increase yield. They reduce hunger more than any other practice. The Haber-Bosch process that actually creates fertilizer was probably the most life-saving thing that's ever happened. It's not great for the environment, but it is great for people not starving to death. So, you have to weigh that. It changes the soil characteristic. It can be beneficial because it provides more nitrogen and phosphorus, but of course it can also pollute the environment by producing too much. Nutrients supplied by the soil can also be, this can be animal fertilizer, this can be chemical fertilizer, this can be naturally occurring minerals, this can be crop residue that degrades. All those things can be counted as fertilizer. That can be organic or inorganic depending on whether or not it has carbon. Manure is inorganic. Soil nutrients are lost with harvest if you remove the debris. So nutrients have to be added back in to retain the fertility, because you put all the nitrogen on the field, then you remove the corn crop, and now you have to put the nitrogen back that you removed when you removed the corn. Usually added at the beginning of the growing season. Now they're actually it's called spoon feeding. So you add some at the beginning, then you add a little more later. As the plant grows, you try and keep one step ahead of it so that you don't lose all that fertility in the middle of the year to a bad rain. So the more frequent the application, the lower the concentration. So you would do just a little at a time, and that's ideal, but sometimes cost prohibitive. These must be applied correctly. You actually have to have a license. You have to take a test to apply fertilizer that you don't just get at Lowe's. A commercial application, it's called a commercial fertilizer applicator license, because there is a huge problem with over application and misuse. There's health issues for humans, and there's a huge hypoxic or dead zone in the Gulf of Mexico. This is my actual job. I am working in the states of Illinois and Missouri to lessen this dead zone. Essentially, as the nitrogen and phosphorus get into the Mississippi River, that comes down into the Gulf of Mexico, and all of that fertilizer means the algae is just going crazy. Like, oh my gosh, we have nitrogen and phosphorus, this is amazing. So imagine it's just a sea of green algae, and that takes up all the oxygen and it kills all the fish. So you have a dead zone in the Gulf of Mexico. And similarly, you have the same algal blooms that you also see those in Lake Erie. And that is from too much fertilizer going into the water. Mostly that's N, P, and K. Sometimes it's other fertilizers, but mostly if you look on fertilizers, you will see an N, P, and K. P is in the form of P2O5. K is in the form of K2O. The label may not indicate what it is. N can be from ammonium, nitrate, or urea. The form is important because the form affects plants differently, so it's good to know what kind of nitrogen you have. If you ask for a fertilizer recommendation, it will be a 1 to 2 to 1 nitrogen to phosphorus to potassium, so 5 to 10 to 5, 10 to 20 to 10, 10 to 30 to 15. Okay.